Hi. Welcome to my presentation today. It's something a bit slightly different than the others. My name is Tom van den Bon, and I'm going to be talking or sharing a bit about our experience or journey playing with robots, virtual reality, and debugging along the way. So first off, a bit about me. I'm a bit of a space satellite nut. That's my actual roof at home, and all kinds of satellites that I like to track and play with and communicate and stuff like that. As you can imagine, my neighbors absolutely love me, especially on that one over there. That's an antenna on a rotator, so as the satellites pass over my house, it actually follows it. Makes a very crunchy noise at 2 a.m. in the morning. The company that I work for is MorganTech. That's my day job. MorganTech is a self-adhesive label stock producer. You most likely have never heard of it unless you're in the label industry. We provide label stock for all the major printers. But if you've been in a Woolworths or a Spar, most likely some of the products have had our labels on there, especially at Discam in there as well. At MorganTech, I run a small R&D department, and we are basically tasked with coming up with innovative ways of improving things in the factory, but also trying all kinds of new technology like robotics, virtual reality, etc. I get to play with toys all day. That's my day job. So you jealous yet? So about 2 years ago, we decided we managed to convince management we need robots in the factory. We want to start playing with them. And the first thing that we wanted to do was improve our quality control line. So we started looking at various robotic arms. The one you see there is a Yaskawa arm. It's typically used, a lot bigger than that one, but typically used in a vehicle assembly line, spray painting cars, assembly and all that. We got a smaller model, and what we wanted to do was use it in our label testing. So it would typically take a sample, and it would do tensile testing, tear testing, etc. Now, while we were busy figuring out this project and playing with the robot arms, the company got an opportunity to go to Brussels for a label expo. So every year they've got a big label expo, tons of people go there. It's the most boring expo in your life, because it's all about labels, nothing exciting. And they asked us to basically, can we do something fun with the robot arm for the show itself? So we took it out of quality control, and we turned it into a robotic bar. So this was TED. TED is for the elixir dispenser. And TED was like a typical mixer bar body. It had like a cup attached to the arm. It's not clear there, but you can see there's a cup there and it had these little lids. And it would, depending on the cocktail that you chose, it would grab the different, the alcohol bits, close the lid, and it would do a little shake, and then it would pour it into a glass. And then just to, because people weren't drinking enough, we decided to make a tequila hour as well. So every hour it would start playing tequila music, that tequila song. And exactly. And we had a little tray with shot glasses, and the robot would fill in all those shot glasses, and then whoever was around just joined in the festivities. Typically these shows end at like 5. They threw us out at 8 every night because we had just too many people wanting to drink. So that was our first experiment into robotics. The next one that we did was looking at mobile robots. So in our factory, our raw material rolls, like this high, about 1 meter wide, they weigh 1.5 tons, between 1 and 1.5 tons, so it's massive big rolls. And we were looking at, maybe we can move some of the material autonomously around in the factory. So this was our first design that we made. We called it Homer from The Simpsons, because it was big, bulky, and dumb. And we started playing with this, and look, we're no experts in robotics or anything like this, so this was all new for us. And the problem was, if you had code running on a 200-kilogram piece of metal running around on wheels and motors, if something breaks or goes wrong, things got dangerous real quickly. After a couple of near misses, we were advised to maybe start a bit smaller. So what we did was we designed our own little, we call it the Pegasus Mini, which is a small little mobile robot with very similar sensors to what the big one has. let's call it our development kit for robotics, basically. It had same LiDAR sensor on there, and the initial goal for this one was to be able to do mapping, localization, autonomously moving from point A to point B. The anatomy of a robot like this is typically, you've got your wheels, because you can't see it on there now, wheels, motors, encoders on the wheels, and a two-dimensional LiDAR. The nice thing about this was obviously if the code crashes or something goes wrong, it runs off and nobody gets hurt. Okay, so let's talk a bit about the software that we've got on our Pegasus Mini. So for those who've played with robotics, there's a package called ROS, Robot Operating System, and it's a typical framework which basically passes messages between the different nodes. Now, a node in ROS is you have a node for each part of the robot, one that collects data about the LiDAR, one that controls to move it around, one that gets encoded data. And these little nodes are essentially small little programs, be it Python, C++, whatever. And they can communicate with each other by subscribing to each other's topics. So either like a LiDAR would, for example, be publishing data, and the node that determines where it needs to go to would be subscribed to it and getting that data, and then such be able to make decisions. As you can imagine, if you have a few sensors, your wheels and all that on there, there's a shit ton of data that's flowing through the system. And debugging starts to becoming a problem. You've got a log file for each node. There is a way to collate it all together, but essentially just looking at one big amount of data. For example, this is the LiDAR that we're using on our Pegasus. It's a two-dimensional LiDAR, and it works with lasers, and basically it measures the time of the reflected light coming back to the receiver, and that's how it determines what the obstacles are around it. Now, a typical output for the LiDAR looks like that. So, it's just a bunch of data, and it comes like, 20, 30 times per second through. So looking at that really doesn't tell you anything, especially when things go wrong. Our first test with the data visualization was to try and make a little web interface where we could see what happens. So this is a typical little web interface. The Pegasus here was actually busy mapping one of the rooms in our factory on the admin side. So you'll see the little red block at the bottom there. That's where it's busy building up a map based on the data received from the LiDAR. And if it works, then no debugging required, all good. But when something goes wrong, it became a pain to figure out what exactly was going on. Okay, so that's the robot side of things. One part that I missed, the RViz. So data visualization in ROS is nothing new, or any robotics platform. And ROS is no different. It had one called RViz. It's essentially what you see there, but it has widgets for each different node in ROS. So if you have a node that has the LiDAR data, it would have a widget for it, one for the encoders, one for the movements, etc. It's open source, but it didn't have all the features that we wanted in it. And when we started looking at the code, this software package is like 17 years old. It still gets updated regularly, but if you weren't part of the development in the beginning, it just becomes a pain to figure it out. And we decided that the time we're going to invest in just adding in the things that we want, let's try something different. Which brings us to the virtual reality side. Not just for porn and games, guys. So virtual reality originally, when we started looking at it, or when I was exposed to it, was the original Oculus Rift. It was nice hardware, but it was tethered to a PC. It was, you were kind of limited, and it was very expensive. And we were intrigued when the Oculus Quest came out, because it was a complete standalone device, not quite as powerful as what the Oculus Rift in performance, but pretty damn good. I don't know how many of you guys have jumped in the Oculus Quest before and played around in there? Oh, you guys need to. If you haven't tried it, it really is a very immersive experience. So we started playing with the virtual reality before we even made the link to robotics. And our main aim was data visualization, using it to show data. Now, I always laugh when you look at business applications for virtual reality, because all of them do the same thing. They put you in an office environment with a shit ton of screens, And Excel spreadsheets, I mean, I can see that on my flat 2D screen. Why do I want to jump into a virtual reality world only to have more screens and more spreadsheets? So our first experiment that we tried before we got to the robotics part was we wanted to visualize our sales data in the company. And we came up with this sales forest concept where a salesperson can actually jump into the virtual reality world, physically walk around trees. And each one of these trees are linked to our customer data. So each tree has specific characteristics. So you'll have a tree that is big, small, the color of the leaves, and all of those would indicate one of those metrics. For example, if the tree was green and it was big, then they've bought a lot from us recently. If there's a lot of fruit on the tree, then they've gone over. We've got like different sales budgets for the customers. They've gone over budgets. If a tree is on fire, then they're over their credit limit. So there's all these, instead of just showing the data, we gave them a whole forest that they could look at, and you could immediately see in the, far away there's a big, nice green tree. Okay, that customer's doing fine. We don't need to, go bother them. But that tree over there is busy dying or is on fire. We need to go investigate what's going on there. And the nice thing about the Oculus Quest, because it's a standalone device, is they're networked. So our environment allowed the whole sales team to jump in there in one go, talk to each other, and together walk through the forest and discuss the different customers that needed to be done. We did add in a small little tablet. You can see showing there, person holding a tablet. So if you would grab onto a tree, you would get the finer metrics, like the actual credit limit amount or the numbers and that. But this was a very big help during lockdown with the COVID stuff, because our sales guys, Joburg, Cape Town, Durban, so they had their weekly meetings inside the sales forest, being able to meet up. And they still do it today. Even though they can travel again, they love jumping into the sales forest. So we found it was quite a nice way of just showing off data and that. Okay, so we've got our little Pegasus development kit. We've got our virtual reality all geared up, and we're running a robot operating system on the Pegasus. The missing link was basically combining it together. Now the advantage, like I mentioned before, for us, because it's all different nodes, we could add in a node that created a connection for external programs. So we found a node that was called ROS Bridge Suite, which allowed it created a WebSocket connection, and it was designed for external websites to be connecting to your robot to show data. So we used the same principle in the virtual reality side. Now, the Oculus Quest development on itself was quite a fun project on its own. So the Oculus Quest is an Android device, completely standalone. So typically most of your Android development tools work for it, but because it's so graphic intensive type development, ideally you want a more graphical game development type engine. There's multiples available that support virtual reality. You've got Unreal, you've got Unity 3D, even the Google Go game engine has bindings for the virtual reality stuff. At the end of the day, we decided to go with Unity 3D, which is essentially the code side is all in C#, and then the front side basically allows you to pull in 3D assets, attach code to it, triggers, and that code it all together. So the first step that we wanted to do was obviously create an environment. Luckily, we had quite a talented little 3D designer on our team, and we, obviously this is virtual reality. You can be on the moon, you can be on a sandy beach. Because we wanted to use this for simulations as well in the future, we decided to spend some time and create a bit of a factory type layout, but also a robotics lab look and feel for it. So once we had that going and we added in our code for jumping into it and that, we could now go explore this world we created. And it was a lot of fun. I think we lost like 2 days, just the whole team walking around in this factory and like picking up boxes, throwing it at each other and doing stuff like that. So, a lot of fun. But what we did realize with typically older managers, if you put them in VR, if you're prone to motion sickness, it's something you need to get used to. The younger guys, no problem there, but older generation, and since they're paying for it, we had to make provision for that. Now, most games already cater for that. There's 2 different types of movement. One is either with a joystick on the controller, where you physically move left, right, up, down, move around. The other way is teleportation. So we essentially added a thing where you could just throw out almost a lasso to the corner or wherever you want to go, press a button, and it instantly teleported you there. It just made things a bit easier for the older generation to move around inside our world and that. So we have a virtual world. We have our robot there. The next thing was now to get the data going on there. Now, you must remember the environment in our virtual world does not match the environment in real life. So we decided to basically keep the robot stationary in the virtual world, because the idea is that you want to be able to interact with it and see what it's doing. So as it's running in real life, it will stand still in VR, but it will show visual data indicators over the robot as it's moving around and doing stuff. So for example, the basic example here is we've got a sphere that was hovering on top of the Pegasus, and based on its actions, whether it was going to be turning left, right, forward, or that, it would change colors. And then the cylinders on the sides was essentially our linear and angular velocities, and that would change, longer and shorter depending on how it was moving. So what's nice about that is as it's driving around, if the sphere changes color, because it made a decision to go left, right, or whatever, you can actually see the movements. And that was for us a very good way of debugging what was going on. Obviously, the next move was now to start adding more complex sensors. Like in this case, it is the LiDAR that we added onto there. It's nice because, as I said, the robot's standing still, but the way it's moving and mapping and that, you can actually see the lines move as objects and obstacles or people walking in front of it comes through. And also the same for the mapping side of things. Now, there's two features that helps us with the VR stuff is the fact that the whole team can jump in there. So we've got developers, Durban, Joburg, Cape Town. They can all jump in there. The robot's in Durban, it's driving around doing its thing, but everybody can look at it and experience and see what it's doing, and we're all working on it together, essentially. The other fun part of it is you can actually pick it up. So it doesn't just have to stay there, you can pick it up, and we can now put on data visualizations on components on the robot. For example, turn it upside down, have a look at the wheel or whatever components is on there, and as the actions are happening in real life, it would change color or show data overlaid on top of that. So, like I said, remember it's not running around because you would be running after it in virtual reality the whole time, which we also don't want. The other last final advantage is, if you're struggling with code and you start bashing your keyboard and it starts getting painful, well, yeah, we can just toss the robot aside. So if the robot is, if things aren't working out, just take out your frustration on the robot. We lost 2 days on that as well because the team members were just throwing the robots to each other and just playing with it. Okay, so honestly, the screenshots that you're seeing on there does not portray the quality of what it is in the VR world. We spent some time trying to make it extra nice, adding some lighting and special effects and stuff like that. Like I say, it can be anything, but if you're going to jump into virtual reality, you don't just want a boring plane to go play on. Do something nice with it. But the idea was originally that I would have a virtual headset here for a quick demo, but with COVID regulations, they really don't like if you're sharing that between a whole bunch of people. Okay, so next steps for us here is that there's a whole lot more that we can do with this. It's a very basic way what I showed you now of the data visualizations. But as you can see with the sales forest as well, you can apply so much visualizations on it, and it tells a different story. Humans are more adapted to visually figure out what's going out rather than just going through lines and lines of log files. So the next step what we want to do is obviously, because of the nice environment we made, we want to now turn it into a simulation as well. So instead of just getting data directly from the hardware, from the robot, have a robot in VR that can actually move in the environment that we created in VR, and then the sensors are all simulated as well. So it would pick up all the data as it's moving around, and then we can try different concepts of that. More sensors, 3D LiDAR, cameras, that's all kind of stuff that we can still add. And then the Oculus headsets has got something called a pass-through. What it basically, remember the Oculus headset's got cameras on there, and that allows it to track your hands and movement and all that. Now, those same cameras, you can actually turn on and then see real life around you. And recently, we've seen that you can now use that pass-through by applying your 3D visualizations on it. So imagine now the real-life robot driving around, looking at it, there's a QR code or something to identify and track it, and those same visualizations that we've got in the VR world is now shown in real life on the robot as it's running around. And the last thing we want to do is, obviously the data visualizations like the sales forest and that there seems to be quite an appeal to try that, especially with business data. So what we want to try is, at the moment it's all internal tools, but we actually want to start adapting it and see if we can't create something more, production friendly, where anybody can, for example, take a spreadsheet of their company's data, and the columns of the data gets linked to the various characteristics in the virtual world. So the fruit can be the first column, the height of the tree is determined by the second column. And if you organize your data properly, then it can be real insightful to see. And also, it doesn't have to be a forest. If you're a transport company with containers, why not have a shipping dock and a whole bunch of containers? And each container is linked to a real life container, and you can go have a look at what's inside, or whatever the case might be. So that's essentially what we've been playing with the robotics and the virtual reality inside of things. We've actually had so much fun and success with it that we started a little side company from it called Proto Garden. The idea here is to be able to release these tools and make them available to the public, but also the hardware. So the Pegasus Mini that you've seen, we've actually now spent time on it to turn it into an actual product. The reason being, we've had quite a few people coming to us, I've got this great idea for robot stuff, but I don't want to get involved in the intricacies of mapping, localization, and all the usual robot stuff. So the Pegasus Mini was now designed, since we've now figured out the mapping and the localization, is to provide a base where if you have an application idea, you just build it on top of that base. For example, we had somebody in the middle of COVID times that wanted to put one of these robots in a hospital with a UV light on top. So at night, it would basically come to life, start moving around, and disinfect the hospital. The other thing that we're doing at the factory now is we're doing stock take with the Pegasus. So our new stock is now, we started adding long-range RFID tags on it. And on the Pegasus itself, we've got a RFID scanner mounted. And every night after 5 or 6, when the guys leave, everything shuts down, little Pegasus wakes up from its docking station, starts roaming the factory, and just starts picking up all these tags. And by the next morning, you essentially have an exception report of what it's seen in the factory, or rather, what didn't it see. And then we don't have to do monthly or weekly stock takes and stop the factory anymore. We get a daily report, and then in between, we can go investigate what happened to it, etc. Also still a work in progress, but it shows, there's so many applications for these robots. Everybody's got a cool idea, but nobody wants to struggle with, how to do the mapping and the sensors and stuff like that. And that's essentially our journey. It has allowed us to, like I say, get the mapping and localization and that all going. And the nice thing about these mobile robots is all the code and all the features that we've now figured out, our next step is to transplant that back into our big Homer robot and get that working inside the factory as well. Cool. Any questions?
Oh, dear Lord.
Yes,
Okay,
Louise.
sorry, from a user experience point of view, how the hell did you come up with the idea of using a forest to show your data?
I wish I had a nice professional answer, but typically, you know how it goes. You go for a couple of beers, you start discussing something, you get around, ooh, a forest, sounds brilliant. And unbelievably, the forest idea worked quite well because a tree comes in so many shapes, forms, and sizes that it makes sense that you can have all these different iterations and colors and around it.
So craft beer, not normal tequila.
No tequila in that one, just beer, all beer.
Thank you.
Cool. Hi. So this is firstly incredible.
Thank you.
I'm a big proponent of VR, but I feel like it's taken extremely long to reach extremely useful applications. I personally thought, as soon as the onset of VR became more mainstream, that for enterprise, for example, for extremely cognitively heavy loads, like development, for example, where you have plenty of moving parts that if you go into a new project where there are thousands of classes doing hundreds of different things, it would be so much easier to represent that visually instead of imaginary, where we're creating these graphs in our head trying to map things. So a question I have about that is, since you've effectively taken the robot and mapped its data visually, how has that actually, what difference has it made in the day-to-day running of it? Has it made it cognitively easier? Is it easier to understand?
We found that it's easier to see what the hell is going on, purely because in the robot's case, you've got so many sensors, so many aspects of this robot, and it's just tons of data streaming by. And by displaying it visually, instead of seeing these whole lines of numbers, you see, objects changing color, changing size, and you know what it means if it does that. So it gave us a real, just by looking at it, oh, wait, it picked up something and it went the wrong way. There's a problem. And all of this is time-stamped in that, so now we can go and look at the finer bits and details of what we need to do. I think humans just, we pick up things a lot more visually than rather looking at long-ass debug logs. That's the experience we had.
And just a follow-up question to that then as well. Since you've created this virtual lab, as it were, have you considered building a replica of your physical actual office and letting the robot run around and sort of using that as I know you said you were thinking of creating a simulated robot and then having it release output, but have you considered sort of testing your robot in a 3D environment that mimics yours without it actually doing anything, going the other way?
Yes, no, we have. We've actually already started on a model. We're not so much for the robotic size, but our next experiment on the VR is to create a digital twin of the factory. So all the equipment, everything that's going on in the factory, because all the data is there in a database somewhere, why not show visually what's happening? So imagine the CEO is on holiday, instead of having to go log on a website, go see, he can jump into the factory, actually walk around, go up to one of the machines, see the data changing as the machine is running. So that exact same models can obviously be used for the simulation side as well, like you say, for the other way around. It's definitely something we're going to be playing with. Well, let's have a look, see if there's any questions on Slack. No, doesn't look like it. Cool. Well, you guys understand the advantages of the visualizations, right? It makes sense, right? I mean, the sales forest idea, that just, the sales guys, granted, sales guys aren't the most technical guys, so we had a good couple of days of training. It goes on your head. Don't walk away without seeing, stuff like that. Yes.
Yeah, I have a question. Do you think it would be possible to kind of create a template virtual environment and have the robot drive around in a real environment and map it out according to what it sees on the LiDAR and all the sensors, so that you basically start with like just a normal room, have the robot run around, and then afterwards you have a model representative of the room itself and all the objects in it?
So you mean like a real room, run it through and then see if you can get a model out of that? Yeah, that's exactly how it works. So the two-dimensional one obviously doesn't do a 3D model, it just creates a 2D plane, but you get 3D LiDARs and cameras as well. And that builds up essentially a point cloud of everything it sees as it does the mapping. Because remember that it's not just the LiDAR, there's other sensors like the wheel encoders. So it knows how much it's moved forward and to the left and that. So it can build up that whole thing and spit out a whole model. So there's no reason why we can't just add a much more expensive LiDAR on there, go map the factory, and then just pull that into the VR and use that. Yeah.
That's pretty cool.
Behind you.
This looks awesome.
Thank you.
What were the challenges in mapping the visualizations against the data? Because I would imagine granularity, for example, is quite, making data look visual isn't exactly the easiest thing.
Yeah, what's the question? Yeah, the challenges we had.
Yeah. I wouldn't even begin to imagine or begin to know.
Look, with most of the things that we've did, you start small, try smaller variations of it. The sales forest, as you saw it there now, was a lot more advanced than how it started. We had 2 free stick trees, just tested out the concept and just started trying it out there. But obviously, there are limitations as to what you can show. There's a reason we still use spreadsheets and all that. But it's a difficult question.
Yeah, I look at it from my own perspective. Like, I couldn't even begin to think how you map like wheel speeds and stuff and you make it look visual for someone.
Well,
it's quite a
wheel speeds is the easy one. So we had little arrows on the wheels, and those wheels would change color. So it wouldn't give you, you wouldn't be able to tell it's exactly 10 miles per hour that it's moving, but based on the color changes, it falls within a range of either going slow, faster, or very fast. And that already gives you a visual idea. We coded the logic of how it needs to move around, so we know if it, let's say it gets an obstacle, it needs to slow down and slowly starts going around it. So you know that those wheels need to start changing colors for the speeds and also for the directions and such. Did that answer?
Yes, thank you.
Cool. Behind you there.
Hey, how much data are you storing, and how are you storing it, and then extracting visualizations out of it in the different ways?
In the robot side or the sales fodder side?
Both.
Well, the sales fodder side, we've got quite a bit of data, but it's your typical ERP data, so everything that you would expect to find in a management system software. Sales data is the obvious one. We know how much sales we've made. We know what the sales is. On the robot side, we don't physically store most of that data. That data just gets streamed live into the simulation. We do have the option of building, where we say record, and it will record all the data, and we can play back the items there. But that is a lot of data.
Yeah. Have you looked into doing that, and then doing some kind of analysis on that data over time?
On the robot side?
On the robot side, yeah.
Yeah, no,
Okay.
we do it.
Okay.
We logged it. We can record it and say we've got the data there, and then we can go back and have a look at it again.
Very cool.
Cool. Well, thank you very much for coming to check out my talk today. I hope it was inspiring and you guys learned something, or it was just fun. And I might be back next year and show you what we've done with VR after that. Cool.